Hello, it's me, and I have a challenge out there that I thought would be kind of an interesting, fun alternative solve to the 4x4. So the 4x4 I always believed is one of the perfect puzzles that are out there because there's so many variable ways you can solve it. So there's a standard way of doing it by reduction where you reduce it to a 3x3 and solve it as a 3x3, reducing the centers and the edges. The other is you can do it as a layer by layer solve the first, second, third, and fourth layer independently. And I also showed one that's parity free where you reduce it to a 2x2, reduce all of these in an AI fashion, and then solve it as a 2x2, and you won't get any parities. Well, here's another challenge that I have, and that's solving it not by reduction, not by layer, not by a 2x2 parity-free reduction, but solve it the way we used to think you had to solve these puzzles, which is side by side by side. So in other words, solve this side, then this side, then this side. Solve as many as you can until you get it to the last two. So it would look a little something like this. So from a scrambled position, you'd start off by just getting one side, the way you would in maybe starting off with layer by layer. So you first start off with one side, let's say the green side, like this. So like this, we first have the first side. Not so much the first layer, which we also have, but the first side. So then we pick another side, say the red one, and just get this side. So by the end of it, we just have this and this, which would look like this. Like this. So what you have is this is in and this is in, so one side, second side, and then you do a third side where you just have the these three, and that would look something like this. Like this. So this is in, this is in, and this is in, but these three are out. So this looks solved, this looks not. And the whole key is that these have to be solved without these being in. So this is solved completely, then this is solved completely, and then this is solved completely. You can start messing things up here as you're solving this, but at the end you have to get it to this. And then you solve the one more over here without solving the other two. So we can just work on this and it would look something like this. Like this. So what you see is there's 1, 2, 3, 4 solved, but these are what's left. Very interesting pattern that you have here. But anyway, so this is side by side where you've solved the first side, second side, third side, fourth side, and now, of course, solving the fifth side necessarily solves the sixth side. So by putting one in, that'll bring the rest to the solved position, which will look like this. just like that. Now, it's a little harder than you might suspect. I will tell you that there's no new algorithms. If you know how to do a layer by layer, if you know how to do a 4x4, then you know how to solve this. Exactly the same kind of algorithms are used with this. But this is the reason why, when you started to learn to solve puzzles, you quickly realized that you can't do one side, because people say, well, I can get one side, maybe I can get two sides, but by the time I get to that third side, boy, that's hard. It was actually layer by layer that you had to do it, or by reduction. So give that a try. That is your challenge. It's a little harder than you might think, but those are the qualifications in order to make it work. Based on how well you're able to do this, I'll come back at you with a solution as to how I do it. Thanks for watching.